Next we are going to find out work done by a constant force. In this case, we are considering a constant force acting on a body. Let it be F. Since it's a vector quantity, I am putting here as a arrow mark. So when this constant force acted on a body, a displacement will be there by this action of force. So in that case, let's take an angle theta between the direction of force and the displacement. Here you can see this is a force and it's directing in this direction, and our object has a displacement in this direction. So angle between the direction of force and the displacement, here it is the theta. Then we can say that displacement of the body in the direction of force is given as S cos theta. That means we are resolving this S vector and we are getting component of S vector here. It is as S cos theta. Okay. So we can plainly write work is equal to F component of force and component of displacement in the direction of force S cos theta. See, the cos theta is the angle between the direction of force and the displacement. So this equation is actually writing as F dot S. So we can take special cases with respect to the angle theta. That means if the angle changes, the force can be either positive or negative or zero. Let's check what are the special cases in this case. For that we are considering if theta is equal to 0, that means the force and displacement are in the same direction. The force and displacement are in the same direction. So what may be the value of cos theta then? Cos theta becomes cos 0, that is 1. Right? So by that equation we can write W is equal to Fs cos theta. It is equal to Fs. Since cos theta is equal to 1 over here, we can write W is equal to Fs. That means work done in this case is maximum. Work done in this case is maximum. It's only the case when theta, angle between the direction of force and the displacement when it is 0, then only the work done by that force is maximum. It will be very clear to you if I am giving you an example. Example is that you think something which is falling from our sky, a body which is freely falling from a certain height. See, this is a ball and it's freely falling from a particular height towards the earth. So the force of gravity and the displacement of the ball are in the same direction, right? The force of gravity and displacement of the ball are in the same direction. So this case is example 4 where work is maximum. So in this case, work is maximum. Hope you understand it. We can also consider another example. If you are lifting a box through certain height, then notice there the displacement is in the direction of your lifting force, right? See, you are lifting a box, so this displacement of that box is in the direction of your lifting force direction. So that case is also an example for work is maximum. Now let's check the second case. When will be work become 0? So if work has to be 0, then the angle between the force and the displacement should be 90 degree, right? We already know W is equal to Fs cos theta. So when theta angle become 90 degree, all we know cos 90 is 0, then W is become Fs into 0. That means W becomes 0. It is purely says that when the force acting on the body and the displacement are perpendicular to each other, then work done by the force will be 0. If the force acting and the displacement are both perpendicular to each other, then work done will be 0. So that is our second case. So let's see what are its examples, or where we can find out the cases when the W, that is work, is 0. That is 0 work has done. For that, you just consider your football is rolling on your floor. A ball is rolling on a horizontal surface. This is our ball and it is rolling on a horizontal surface. Here you can see the weight the weight of the ball is acting on the surface is downward, right? But the displacement of that ball is around the direction of that horizontal surface, right? The weight of the ball is acting downwards, and reaction on the ball, that means the ball is moving horizontally, right? They are both perpendicular. That means here the angle between them is 90 degrees. They are both perpendicular. So work done in this case is 0. Work done by these forces is 0. We can consider another example. Here is a man. You see, this is a man, and he is walking on a level road, and he is walking on a horizontal road, but by carrying a luggage on his head. See, there is a box on his head. How does work become 0 in this case? Or is the work is maximum in this case? Let's check it out. Here you can see that the force of gravity acts on this box is vertically downwards, right? The force of gravity act on this box is vertically downwards. But the man is moving in a direction perpendicular to the direction of this force of gravity, right? This man is moving horizontally, he is moving like this, but the weight on his head, the force which is experienced on his head is acting downward. Since both of them are mutually perpendicular, then we can say that work done by the force of gravity or against gravity on the box is 0. Okay. Here we can say that work done by the force of gravity or against gravity on the box is 0. So children, here we have seen two cases of work. Work can be maximum, work can be 0. And we have seen how they differs each other and a perfect example for it. You can find your own examples and relate the concept and enjoy the physics. Thank you.